This video is about solubility curves. A solubility curve shows you how temperature affects solubility. Solubility is how well something dissolves. And if you look on the y-axis, on the left, solubility is given in grams per 100 grams of water. So it's the amount of grams that will dissolve in 100 grams of water. 100 grams of water is about 100 milliliters. These lines all go up, except sodium chloride at the bottom isn't affected much by temperature, but all of them generally go up, which tells us that as temperature goes up, they dissolve better. I want you to think about maybe getting unsweet tea at a restaurant instead of sweet tea, and then you try to put sugar in that iced tea. It doesn't dissolve. But when the tea is hot, it dissolves much better. The sugar dissolves better when the tea is hot. And that's because you guys know that when temperature goes up, the particles move around faster. So think about the water molecules moving around very fast when the tea is hot, bumping into the sugar, getting it to dissolve. But when it's cold, those water molecules are not moving around very much. The tea molecules are not moving around very much, and they are bumping less into that sugar, and it's not going to dissolve as well. So generally, things dissolve better when the temperature goes up. A graph like this, though, also allows us to get some numbers. So for instance, at 40 degrees, at the bottom, if I draw a vertical line up, I can see how much each of these solutes will dissolve in 100 grams of water by reading the y-axis. So I can go to the green line, I can go across, and I can see how much is going to dissolve at 40 degrees. I can go to any one of these, and I can figure out, according to what the y-axis is telling me, how much is going to dissolve at 40 degrees. If I go to 90 degrees and I go up, you can see the numbers are going to be higher. More can dissolve at 90 degrees. I can also start on the y-axis, and I can draw a horizontal line. So for instance, let me just get rid of that. So if I draw a horizontal line, let's say over here, I can figure out at what temperature 120 grams is going to dissolve for each of these. And then I'm going to read the x-axis. So the blue line, potassium nitrate, I can go down and I can say at 50 degrees, I'm going to dissolve about 120. The red line, I can go down, I can say, I'm going to need 70 degrees to dissolve 120 grams of that substance, and so on. So you can get data from this. If I look on the right-hand side, if you look on the right-hand side over here, it says that a point below the line represents an unsaturated solution. So if we're dealing with, let's say, sodium chlorate, again, the blue line, if I'm at a point below that blue line, that means I can dissolve a little bit more still before it becomes saturated, because a point on the line is a saturated solution. So anywhere along any one of these lines, you have a saturated solution. That means you've got the maximum amount that you can dissolve. If you're below any one of these lines, like if I'm below the red line and I'm dealing with this red substance, which is potassium nitrate, I can dissolve some more before it becomes saturated. A point above the line, that represents a supersaturated solution. So if I was over here and we're dealing with the sodium chlorate, for instance, I have got this amount too much in that solution. And if I'm able to dissolve that amount, we call it a supersaturated solution. So a point above the line is called supersaturated, a point on the line is saturated, and a point below the line, we call that unsaturated. I hope this helps you to understand solubility curves.